Hello guys, in today's class we will discuss about equilibrium and want of equation. We can say we will discuss some concept, there are some questions which are clubbed questions of two chapter concept. First chapter is equilibrium and second one chapter is the thermodynamics. So when the concept of these two chapters they club and then they can make a good question. So first of all we have to understand the equation delta G is equal to delta G naught plus 2.303 RT log QC. Now what is QC? QC is the reaction quotient, means concentration of product divided by concentration of reactant. In equilibrium conditions we can say QC become KC and at equilibrium delta G is equal to 0. So at equilibrium we can put delta G is equal to 0 and QC is equal to KC. When we put these two values in above equation we will find the equation that is delta G naught is equal to minus 2.303 RT log base 10 KC. We can write this equation in another two form in the form of natural log like delta G naught is equal to minus RT ln Kc. Because we are using natural log so we will eliminate the 2.303. Another form of this formula we can write like Kc is equal to E minus delta G naught upon RT. There is another equation which we have learned in our thermodynamics chapter, that is delta G naught is equal to delta H naught minus T delta S naught. Here delta G naught is the standard Gibbs free energy change and delta H naught is the standard enthalpy change and delta S naught is the standard entropy change and T is the temperature. When we put the value of delta G naught from the above equation, that is minus RT 2.303 RT log Kc, we will put the value of delta G naught in this equation. So we will get equation number 1, that is minus 2.303 RT log Kc is equal to delta H naught minus T delta S naught. Now if I divide the whole equation with 2.303 then we will get a new equation. That equation will be log Kc is equal to minus delta H naught upon 2.303 RT plus delta S naught divided by 2.303 R. This equation is similar to equation of straight line. Y is equal to, that will be equal to y is equal to minus m, that is minus m into 1 by t. 1 by t is equal to x plus c. C means intercept. So this equation resembles the straight line equation. So when we plot a graph between log Kc and 1 by t, then we will get a straight line with negative slope like this. This graph we are making for endothermic reaction, because for endothermic reaction delta H is equal to positive. Delta H is positive for endothermic reaction. So we will get the negative slope. The slope of this reaction will be equal to minus delta H naught upon 2.303 R. And intercept, from this equation we will get the intercept is equal to delta S naught upon 2.303 R. So intercept means OA, that will be equal to delta S naught means standard entropy change divided by 2.303 R. If we are talking about exothermic reactions, so for exothermic reactions, because delta H for exothermic reaction is equal to negative, that's why this negative and negative become positive, so slope will be positive. For exothermic reaction slope will be positive. For a equation or for a reaction, if K1 is the equilibrium constant at temperature T1 and K2 is the equilibrium constant at temperature T2, then we can write two equations like log base 10 K1 is equal to minus delta H naught upon 2.303 RT1 plus delta S naught divided by 2.303 R. At T2 temperature, we assume that the equilibrium constant is K2. So for log K2, the equation will be log K2 is equal to minus delta H naught divided by 2.303 RT2 plus delta S naught or divided by 2.303 R. From equation 2 and 3, we will get the equation that is log base 10 K2 upon K1 is equal to delta H naught upon 2.303 R 1 by T1 minus 1 by T2. Actually, this equation is very important equation. This equation is known as want of equation. Want of equation. It is useful equation by which we can calculate the enthalpy change, standard enthalpy change. If T1 and T2 is given, then we can calculate the standard enthalpy change. Another form of this equation is log K2 upon K1 is equal to delta H naught upon 2.303 R T2 minus T1 divided by T1 into T2. So from here we can calculate the delta H naught. Delta H naught will be equal to 2.303 R T1 into T2 divided by T2 minus T1 log K2 upon K1. Now solve some questions related to this concept. Draw the graph between log Kc and 1 by T for exothermic reaction. As we have discussed from want of equation, exothermic reaction, because in exothermic reaction delta H is equal to negative. So our slope will be positive. Slope will be positive. So we can represent the graph like that. It will be straight line. Here will be log Kc 1 by T. Slope will be positive and the intercept and that slope will be equal to delta H naught divided by 2.303 R. 2.303 R. And suppose this point is O and this point is A. So intercept means OA will be equal to delta S naught means standard entropy change divided by 2.303 R. So that will be our answer. Let's see another question. Variation of equilibrium constant Kc with temperature T is given by want of equation. The equation is given that log Kq, K equilibrium, is equal to log A minus delta H naught upon 2.303 RT, and there is a graph is given, tan inverse is also given, as well as OX means intercept value is equal to 10. Now we have to find out delta H naught. It's very simple. Let's see the value of slope. Slope is equal to minus delta H naught upon 2.303 R. 2.303 R. And the slope is tan theta, that will be equal to 0.5, that is given 0.5. From here we can calculate delta H naught means standard enthalpy change. So delta H naught is equal to 0.5 into 2.303 into R. Value of R is 1.98 means approximate to in calorie. In calorie, if we want to calculate, then it's approximate equal to 2, or exact it is R is equal to 1.98. So our answer will be 2.303 calorie mole inverse. 2.303 calorie mole inverse. Now solve the second question. Second question is we have to find out equilibrium constant at 298 Kelvin temperature. Okay, so we will write the want of equation again. So our want of equation is delta H naught means log KQ, log K equilibrium is equal to log K equilibrium is equal to 10 minus 0.5 divided by 298, because the delta h naught upon 2.303 r, that is slope, and it is given 0.5, and t is given 298, and log a, that is given 10. So we will put the value, and when we solve it, our answer will be log k equilibrium will be equal to 9.9983. 9.9983. To solve this, we have to take the anti-log. So anti-log of this value will be equal to, means k equilibrium will be equal to 9.96 into 10 raised to power 9. 9.96 into 10 raised to power 9. So that will be our final answer. So that is the questions which are a mixed question of thermodynamics as well as equilibrium chapter, in which we will use the want of equation and the concepts related to this. Thank you.